how do we really measure intelligence in animals? For the longest time, we thought we had a pretty simple answer, but it turns out we might have been getting it wrong all along.
So let me just ask you a question right out of the gate. What's the most intelligent animal on Earth? I'm guessing most of us would say humans, right? Maybe dolphins or chimps as runners-up. And that's usually based on one big assumption. Bigger brain equals more smarts. But what if the facts tell a completely different story? Okay, let's just look at the raw numbers here. A sperm whale's brain, a whopping 10,000 grams. An African elephant is rocking a grain around 6,000 grams. And us, our little human brain, comes in at about 1,350 grams. I mean, in terms of pure size, it's not even a contest. We're tiny. So right away, we've got a problem. A paradox, really. If brain size was the one true measure of intelligence, then whales and elephants should be running the show, not us. Clearly, there has to be more to it than just size. And that brings us to our first section, the brain size paradox. We really need to dig into why our most basic assumption about brains and intelligence is just so, well, wrong. You know, for decades, scientists tried everything to make this big brain idea work. Absolute size, as we've seen, is out. Then they tried relative brain size, the brain-to-body mass ratio. The problem there, that would make the tiny shrew a certified genius, smarter than us. So that didn't work either. Even when they got really fancy with complex math, like the encephalization quotient, the results were still weird, putting dolphins way, way ahead of chimps in a way that just doesn't quite line up with what we observe. So what's the deal? Well, it turns out we've been looking at the wrong thing. It's not about how big the brain is. The real power comes from its processing capability, how fast and efficiently it can actually handle information. Think of it like a computer. It's not the size of the box that matters, it's the speed of the processor inside. And this leads us to a much better, more accurate measure, information processing capacity, or IPC. You can think of IPC as the performance specs for a brain. It looks at the good stuff, the number of neurons, how tightly they're packed together, and how fast they can talk to each other. Let's break that down real quick. IPC basically comes down to three key things. First, the total number of neurons in the cortex. That's the outer layer of the brain that does all the heavy lifting, the higher thought. Second, neuron packing density, which is just how close together all those neurons are. And third, the speed of the signals zipping between them. You combine those three things and suddenly you get a much clearer picture of a brain's true potential. And boom, this is what solves our original mystery. The human brain, yeah, it's small, but its cortex is incredibly dense with neurons, and the signaling speeds are lightning fast. That gives us a super high IPC. A whale's brain, on the other hand, for all its massive size, has a much lower neuron density and slower signaling. It's like having a biological supercomputer versus a gigantic but much slower machine. It's all about quality, not quantity. But a powerful computer is nothing without good software, right? A brain's hardware is only half the story. To really get what intelligence is, we need to look at the software it's running. And that brings us to the secret culture of chimps. Just look at this incredible moment. This was captured in the Thai forest in Ivory Coast. What you're seeing here isn't just a chimp with a rock. This is school. This is a mother actively showing her kid how to use a stone hammer and an anvil to crack open these super tough kula nuts. This is a complex, vital survival skill being passed down not by instinct, but by learning. And folks, that right there is the very definition of culture. We're not talking about something that's coded in their genes. Culture is any behavior that gets transmitted from one generation to the next through social learning, watching, copying, and teaching. It's the original form of information sharing. And here's the kicker, the absolute proof that this is learned. The chimps in the Thai forest are masters at cracking these nuts. But just a few miles away, right on the other side of the Sosandran River, the chimps there don't do it at all. And it's not because they can't. The same nuts and stones are sitting right there. That river acts as a literal cultural barrier, separating two totally distinct chimp traditions. This discovery was absolutely huge, but it was just the beginning. It turns out that this was just the tip of the iceberg, revealing a rich and varied map of chimp traditions all across Africa. So for decades, you have all these researchers at different sites all over the continent, from Ivory Coast to Tanzania. And they start talking to each other, comparing notes. They quickly realized that all the unique little behaviors they were seeing weren't just random quirks. No, they were patterns. Each community had its very own set of customs. So just how many traditions are we talking about here?
After this massive scientific effort, compiling over a century and a half of combined data, researchers identified 39 distinct behaviors that qualify as cultural variations. That is just staggering. It's a level of cultural richness we've never seen in any other non-human animal.
And we're not just talking about big, obvious stuff. The details are amazing. Take something as simple as getting rid of a bug you find while grooming your friend. In the Thai forest, they'll mash it on their forearm. In Gombe, they'll squash it on a leaf. And over in Budongo, they'll actually inspect it on a leaf first. Same problem, 3 different, unique cultural solutions.
Or how about this one? Ant fishing. In communities like Mahale, it's totally customary for chimps to find just the right stick, poke it into an ant nest, let all the angry ants swarm it, and then slurp them up as a tasty snack. It's a learned skill, a local delicacy, you could say. But maybe my personal favorite is the grooming hand clasp. In some communities, like Kibale and Mahale, 2 chimps will often clasp hands over their heads while they groom each other. It's like this little social ritual, a secret handshake. And yet at Gombe, one of the most studied chimp sites in the world, after 40 years of observation, it has never, ever been seen. Not once. It's a custom that's completely unique to certain groups. So, what does this all mean? Where does this leave us? Well, it completely forces us to throw out our old ideas and rethink what animal intelligence even is. It's not just about the brain's raw power. It's about what you do with that power. So here's the big takeaway. True intelligence seems to be this powerful combination of 2 things. You need the biological hardware, a brain with that high information processing capacity. But that's not enough. You also need the software, the ability to learn new things, to create, and to pass that knowledge on, building a culture. The very fact that we share this ability for culture with chimps suggests its evolutionary roots run deep, way back to our common ancestor. But, and this is a big but, human culture has something special, something scientists call the ratchet effect. We don't just pass ideas on, we build on them. We improve them generation after generation. A chimp's stone hammer today looks pretty much the same as it did 100 years ago. Our tools have gone from stones to smartphones. That ability to build on the past is what truly sets us apart. Ultimately, finding these rich, diverse chimpanzee cultures is a total game changer. It forces us to look at our closest living relatives not as simple creatures driven purely by instinct, but as complex social beings with traditions, customs, and inner lives far, far richer than we ever gave them credit for. And that leaves us with one last, really important question to chew on. If it took us this long to see something as complex as culture in an animal that we share 98% of our DNA with, what other incredible things, what other forms of intelligence are we still completely blind to in the world all around us?